Okay, so today I will present the paper LightRAG, which eventually is the simple and like a kind of fast retrieval method for the augmented generation. It is a kind of like alternative for the RAG, and my name is Panshujan. So in this we basically dive into the main four features that are the overview, main contribution, evaluation, and the results. Means how the that light drag is evaluated, and also that limitation and the future one. Talking about the overview of the problem statement, it is a kind of things like it is a main crux, like why the light drag is kind of come into the play. Eventually, we have the different basic rag methods, also the graph rag and different rags which are already present in the market. But the problem with that is eventually they have very limited structure knowledge. Integration, current rag frameworks fail to effectively utilize the structured data like the knowledge graph, missing deeper context, entity relations, scalability challenges like many of the rags is kind of not scalable to the large data set. They are eventually come like work upon only the mid size or the low size data set, which eventually make it difficult to eventually get the kind of the information from the large set of data. Also, the contextual thing, which is a kind of main crux of any of the like algo of the RAG algo, is eventually that any of the flat data representation, which eventually is a kind of limitation of the every RAG method which is present. It is a kind of a lack of ability to capture the nuanced relationship between the entities, also the leading to the less accurate responses. Fourth is the kind of the limited adaptability to the new information. Like if I am adding any new information in that case, that whole model have to like change its like structure. Also it's have to like retrace back to the all to the like the kind of extraction it has made over the all of the data set. Also, the last is the kind of the complexity of query handling. Like if I ask some complex query, in that case many of the RAG are not able to provide a good extraction, or you can say that the main part, that is the context handling, is not properly handled by that RAG method that is present. Now here the LightRAG come. So the basically LightRAG is a kind of advanced retrieval augmented generation, that is the RAG only. It is a framework that basically integrates the graph-based knowledge structure to the enhanced large language models, which is a kind of the dual retrieval method. Dual retrieval here means that the low level and the high level retrieval, which eventually enhances the comprehensive information retrieval. Like we know that the capturing of the context is very important for the light RAG. Second, it is eventually designed to address the limitation of the traditional RAG method. As we know that the traditional RAG method eventually did it divide the, let's say the I have the sentence, it will divide the big sentence or the big data, big paragraph into the chunks, and 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 it will search each chunk for the kind of the like if I given the query corresponding to the query, it will kind of find the cosine similarity, or any kind of like the you can say that the similarity index it will find between the that chunk and the query, and on the basis of that it eventually give us that result, like okay, like this is the more appropriate thing on which we have to work. Like we have to summarize, we have to like generate that answering from that. So the main contribution or the solution which is to be proposed by the light rag is divided into four parts. Like the first solution that is proposed is a kind of the graph based text indexing. Second is the dual level retrieval mechanism. Third is the retrieval augmented answer generation, and fourth is the complex. Like it is kind of analysis of the complexity, like how complex is the LightRAG, means how optimally it is handling the things. So here comes the graph-based text indexing. It is a kind of you can say the core feature of the LightRAG. It eventually allowing it to construct a knowledge graph that captures the relationship across the documents for deeper understanding and the efficient retrieval. The key elements includes the firstly the entity and relationship extraction, which eventually extract the nodes, which refers as the entity, and the edges, the relationship, using the LLM powered functions. These function kind of the you can say that the crux of the graph based indexing, which eventually helps us to identify like what is the entity. Like entity, you can say that the entity can be anything, any of the, you can say the location, person, and how it is related to the other sounding text. Like you can say the uh, you can say that the how the that it is related to the context to the like context given as per the its sentence. Second is kind of the LLM profiling. It is a kind of the process in which the key value pair is generated, which eventually is is kind of the key is the kind of the entity, and the pair, like the value, that is a kind of description of the key, like how the key is kind of, you can say that how that key is present, like what is the meaning of the key in the in that sentence as per the context. So it will like help while generating the answer, while uh, answering the context. It will add you more info to the like that generation. Third step is the kind of deduplication. It is a kind of optimization step which basically optimizes the graph by merging the duplicate entities and the relationships. The advantages of the graph indexing is a kind of the enhanced retrieval performance, like the key value pair that we have derived from the grapher. It basically ensures and give the more precise retrieval, surpassing the traditional embedding matching and the inefficient chunk traversal. Like as we know that the in the traditional leg, the sentence is divided into the chunks, and the each chunks are traversed like in the sequential manner to see the kind of, you can say that that sequential search as per the query. But in this, we have created the graph of the information, which and we can apply the graph algorithm for the faster retrieval. We will come to the method with the LightRAG used for the retrieval of the information. Second is the fast adaptation to the incremental knowledge. As we have discussed, like one of the drawback is that uh, like uh, like if any new information is added, in that case the kind of whole process is repeated again and again, as the new information is added to the KB or the kind of to the our data set. But in the case of the kind of the graph base, it is kind of just see the relation of that entity with the with the other entity. Whole graph is not built again and again. So that so so this kind of incremental knowledge is kind of make the things more computational friendly. Second is the dual level retrieval. This is a kind of core algorithm which eventually kind of take the things from the, you can say that it will take the things from the that graph that we have created in the graph based indexing, and it will extract the information from that graph. The dual level is corresponding to the like the low level and the high level retrieval, which like solves the two types of query. Like first query is that focus on the precise detail and the specific entity. Example, who wrote Pride and Prejudice. Second, abstract queries like address the broader concept or theme. Example, how does the AI influence the modern education? So, so you can see that the first query is kind of the detailed one. Second one is kind of the abstract, like you can see like seeing the thing in the broader perspective. So, so let's talk about the types of retrieval. First is the low-level retrieval. It is a kind of the retrieval which works upon the finding the specific entity and relationship. Let's, if I take an example, let's say let's say that the that we have taken the question of the AI, like the how the AI thinks, like how that AI is impacting the modern education. So this low level table see the find the entities which is responsible, like to the specific case, like these are the parameters, or these are the factors which is is specifically kind of you can say that influencing that modern education in the kind of core thing. And talking about the high level table, it eventually see the things at a broader perspective. Let's say like in the AI also there are the different branches, like you can say that they are the types of AI which is influencing the modern education in that different way. In that case, we are seeing the things in the broader perspective. Second, not the second, like kind of combining these two, which gives us the kind of the both the powers. First power is to get the entities which are very much related to the topic. Second, we also get the broader perspective of that specific topic. Like we are not seeing that just topic, we are also seeing the notes. If I talk about as per the graphical thing, we are also seeing the nodes that are closely related. As per seeing the broader view, that are closely related to that specific kind of node, like the AI node. We can also see the other nodes. So this eventually gives us the kind of power to generate the answer in a kind of more intuitive and the more defined way. Okay. So now we have come towards the kind of that answer generation, like the retrieval augmented answer generation. So here it is a kind of you can say that the kind of last step which LightRAG do. Like we have created the graph, we have eventually extract the information from the graph as per the query. Now we have to generate the answer as per the that result we have got from the low level and the high level retrieval. In that case, we uh, we eventually do the two steps. First step is kind of the using the retrieve information. From that information, which we eventually uh, take the names, any of the entity, like the it can be location, it can be name, it can be anything, any specific thing. Then we combine the that relative entities to the relationship into a unified data space for answering the queries. Like let's say we have taken the subset, like that subset includes all the like the information at one place. Like these are the entities, these are related in this way. We have also we also have that like key value pair. We know like how this entity is described as per the context. So from that all that thing, uh, we have a good understanding, uh, like how the information is represented which information we have to use for the answer generation. Secondly, context integration. This step basically merges the query, like we know, like we are answering the query. This eventually merges the query with the re- retrieved data into a single input, and this input is feed to the LLM, which eventually generate the answer as per the query intent. So, so you can take this step as the kind of the step which eventually merging all the things. The kind of the query understanding, that retrieval data also include that the entities, the description of the entity, and also that the you can say that original text is also provided for the kind of the better understanding. Okay, like what are the important factors that are extracted from the that original information, and there might be the case like the LLM have to refer to the original like the text for specifically like getting some details which might add the more explanation or the more detailed understanding towards the answer generation. So uh, so in this that we know that the while the generation, that these two things are the main core before the generation. We have to do like the that graph based indexing, that they are LightRAG used the LLM to extract the entities and relation from the text strings without additional computation overhead. Second is the graph-based retrieval. For queries, the LLM, it is the entities and the relation instead of document chunks, which eventually reduce the kind of overhead and ensure the faster performance. Like it is a kind of you can say that the divide and conquer technique. We are not searching to the whole data set. We have divided that document into the chunks, and we are processing that chunks individually so that our processing will be fast, and and at the end we can combine that retrieval uh, to the one place. So this is the kind of the, you can say as the architecture of the LightRAG, how the LightRAG works. So here you can see that on the let's talk about from the left to right. On left we have the document, and we have taken the chunk of a big document. Now we have applied the three operation. First is the that deduplication, profiling, and that entity relationship extraction. As we can see that we have taken the word beekeeper. We know like there can be the instance as we are seeing in the document, there can be the instance in the first instance the beekeeper is written in the full capital, and the second it is it is written as the plural and also the lowercase. So it is a kind of the duplicate entity. So the duplication step basically remove the second one, and only take the first instance, the kind of the unique one. Then we do the profiling. Now the this is a step where we create that key value pair. Here is the key is the entity, as we know that the beekeeper, and the value is the kind of description of the beekeeper, like how the beekeeper is defined as per the context of that chunk. So here you can see that the a beekeeper is a person who that that all the kind of description is defined in the value. Third is kind of the entity relationship, uh, li- uh, kind of the, it will define the relationship between the beekeeper and bees. Uh, like let's say it is a kind of that what beekeeper do to the bees, like beekeeper observes the bees. So it will define we have the two entity, beekeeper and bees, and they are related on the base of the observe. like the beekeeper is observing the bees. Now that graph is created, that index graph is created with the help of this of information. As you can see that the each node have the entity name, entity type, description, and the original chunk ID. That I have said that the original chunk is also embedded, like also taken into consideration. Like while we are providing it to the LLM, so there the LLM can use this original chunk to see to add the more explanation towards the answer generation. Now we provided this with a query to the LLM, which uh, which eventually generates the answer. But before the generation, we have to do kind of step, that the low level and the high level like retrieval. Here you can see that from the low level retrieval, we get the low level keys, and from that high level retrieval, we get the high level keys. And you can see that in the high level keys we have the broader perspective, like the agriculture, production, environmental impact. But in the low level keys we have that is specific information, like the beekeeper, that is related to the beekeeper only, like the beekeeper, as we know that the bees give the bees are also good honeybee, and they live in the hive. So the all information that is related to that specific term is is very well retrieved by the that low level retrieval. And the high level retrieval also done the good job in retrieving that kind of the broader perspective. And then we then provide this to the LLM, and 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 that LLM will generate the answer as per the all the information, all the processing it have given to it with the query and the original text. Now the evaluation result. So so uh, so by evaluation, there are the kind of the four questions, or the kind of the four like perspective in which the evaluation is can be seen. First question is the how does the light rag compare to the existing rag method in performance. Second, how do that dual level retrieval and the graph based indexing enhance the generation quality. Third, that the word specific advantages does that LightRAG demonstrate in different scenarios. Fourth is a kind of the that what are the cost or the adaptability of the LightRAG. So the dataset that are used by the LightRAG for the evaluation is kind of agriculture uh, dataset, which eventually focus on that beekeeping, crop production, and the disease prevention. CS kind of the computer science datasets, which eventually focus on the big data recommendation system and the machine learning. Third is the legal one, which eventually uh, is the kind of the corporate law compliance and the governance topics. Fourth is the mixed, which includes the cultural and the historical philosophical test, which eventually kind of the literature things. Now, now the model data into the comparison. It is a kind of the that data for rag, like the naive rag, which eventually work upon the like the it will divide the document into sections, and it will use the embedding based retrieval. Like it will get the embeddings, and let's say like it is using the cosine similarity. It will see the like that the which chunk is very similar to the query, and and it will give that chunk, and based on the chunk that the answer is generated. That the argue rec, it will break the query into subqueries for the retrieval improvement. Like previous step is done, then but in argue rec, it will also divide the query into subqueries. So kind of it will have to like process the less thing, and also that query part can be handled more effectively. Third is the Heidi, which eventually generates a hypothetical document to guide text retrieval. Like it will kind of define the past, like how this query to be handled. Fourth is the graph rag. It is a kind of, you can say that, very similar to the light rag, but light rag outperform this graph rag in many cases. We will discuss this further. And the baseline comparison, we have, it is a kind of the comprehensiveness, diversity, empowerment. These are the three main kind of comparison parameters which we are taking. First is to address all aspects of the query. Diversity, which is to provide the richer perspective and the insights. Third is the empowerment, enabling the users to make the informed decision. Now, what is the observation? So the observation is uh, uh, that the our light rag is constantly outperforming all baseline models. As we know that the light rag implemented the kind of the that dual that graph based indexing that is similar to the graph rag, but the main part is that the dual level retrieval. That kind of retrieval is kind of make the things kind of giving more context to the LLM for the answer generation. It is giving the both the context, like the low level context and the high level context, which eventually enhance the quality of generation. We can see specific in the, especially in the legal data set, it will demonstrating the notable gains in the diversity and the empowerment metrics. As we know that the diversity corresponds to the richer perspective and the insights, and the em, empowerment corresponds to the enabling the user to make the informed decision. Second, that the light reg also shows that the how that dual level retrieval and the graph based indexing is effective. Like you can see in this image, like how on every parameter that the light reg is outperforms every model that is currently present uh, into the rag, like you can say the multiverse, like rag community. So now we talk about that the limitation and the future works of the light rag. So yes, man, like light rag have some limitation, you can say that the li- uh, light rag still have to work upon that optimization process for the large data set. Still, there are the instances on which that the light rag face difficulty, or the computational, not the computational, but the difficulty in processing that kind of the, you can say that that the large on the large data sets, it eventually not able to perform well. Also, it have to like work upon that optimization of the that graph generation, like in the same in the case of the that large data set, while generation of that graph, it eventually misses some entities which are which are kind of important but not included in the graph. And also, let's talk about the limitation of the current drag. Like I have already discussed. So as we know that the current drag system kind of rely upon the text chunks, which is like kind of the top k context, like as per the like cosine similarity or the similarity between the query and the chunks. It will only take the top k ones, and this eventually not give the full view of that query, like the that how the query has to be answered. So the quality of the answer generation is kind of the you can say on the mediocre side or the low side. Second, it it eventually faced the challenges with the dynamic updates, kind of the depending upon the resource incentive and the brute force searches, kind of for handling the large scale updates. Like as we know that in the LightRAG, there is the concept of the incremental update, which eventually improve the computational by data extent. So so yes, like the advantage of the LightRAG include that thing only. Like it enables the dynamic knowledge graph updates for timely update and the accurate responses. Also implement a dual level retrieval paradigm for the faster and the more efficient information retrieval. As per the large language model for the graphs, there is kind of the three methodology. First is the GNN as the prefix, like the graph-based network, that is GNN. Process the graph, the data first. Yeah, sorry for the thing. So so that the GNN will process the graph, the data first, turning it to the token like the test like, and then give to the LLM for the understand. Second, as the LLM prefix, like the LLM will analyze the graph data, like the nodes, edges, and the as we know that the nodes division to the entity and the edges division to the relationship, which eventually create the better input for the GNN. Third one is the LLM and the graph integration. That is kind of the LLM and the GNN work together, directly combining their strength for the better performance. Like as I already talked about the limitation of the kind of that LightRAG, like scalability, that like it is efficient for the mid-size data set, but it needs the optimization of the large scale data set graph and the real-time update domain specific performance. Like as we can see in the legal one, it is performing well, but uh, but like as the new domains are adding, uh, in that also LightRAG has to be has to be kind of timely capture that domain things more intuitively. Third, uh, it is a kind of query and update efficiency. Like incremental updates can cause a minor latencies. Like yeah, means while it is seeing the listen of that new data with the other entities, there is kind of the time gap or the latency in that case. So like we have to plan to kind of improve that query handling and the update speed. So this is all about the LightRAG, how it how it is better from the other, and what is the limitation, how that LightRAG works. We have discussed all the things. Thank you.